All right, we're going to do a pull-out test number 5 here. We've chosen a lap area to do this in, where we have some fabric tape and some elastomeric coating that's been applied. Sometimes you can get a little bit of additional rusting under these areas, maybe a little bit of water entrapment, water retention, and you can have even a more compromised situation right here. What I'm going to do right here is I'm actually going to put this. I'm actually going to put this test. We're gonna come up to right here with our screw. So what we're doing is we're actually coming through 2 layers of metal, because we've got a layer underneath here that goes up to about here, and we've got and of course this layer coming down. So if we go right here in this area here, or actually anywhere up in here, we're going through 2 layers of metal. So I'm going to go right here, and we're going to kind of see if we get a different pull-out value by going through 2 layers of metal than we did from just going out in the surface area, where we only have 1 layer of the 26 gauge metal panel. And we'll see what we come up with here. Check our gauge. Always be sure to check your gauge. Make sure you're back down to 0. Remember, we're pulling. We've screwed that screw through 2 layers of 26 gauge metal because of the overlap that we have here. I'm going to be surprised if we get a lot more pull-out value, but we'll see what happens here. I think we're going to get a lot more pull-out value. We're already up over 500 pounds, so we're getting a lot more. So, okay, finally that popped. Keep in mind we're through 2 layers, so we got a pull-out value there of 500, right at 500, just a tad over 500 pounds of pull-out value. So the double layer of 26 gauge metal did indeed make a big difference on the pull-out value. Of course, bear in mind you're not going to have these 2 layers everywhere, but you will, depending on the installer and the manufacturer. Depends on how far that this bottom panel lapped up past this purlin, because there's actually a roof purlin right here. You can see from the screws here, there's actually a roof purlin. These purlins are generally on a 5-foot center on a red iron type steel pre-engineered building. So if you look right here, you can tell, yeah, that's going to be right out on a 5-foot center from that purlin to that purlin. So the area in between here is basically, there's no support under it, but this particular type of panel will support, or will span 5 feet fairly well in a 26 gauge. Although you still have to be careful, or you will end up with a lot of kinks in this, like you can see here. Another thing too, while I'm on this kink right here, if you'll look at this little place right here on top of this, I've actually seen where they pushed the panel down and had a pretty good kink. Well, actually, okay, you can see right here, I was going to mention, I've actually seen a hole come in the panel, and sure enough, right here, there's a hole in this panel right here. There's a crack right there in that panel. And the reason that's there is because the installers or maintenance people have been walking on these panels, and they've kinked this, and you see what just a little kink, it compromised this metal enough to the point that you ended up with a little slit right there. That's very unlikely to leak, but still yet, it's not something that you want in your roof. That's really really interesting. I didn't really see that before I before I looked at that, but you'll see it quite a few times in some of these kink areas where you're basically walking on the roof and someone puts their foot up on the panel like this. It's very easy to kink it. You would think that it would be worse down in the pans, but if you'll walk in the pans of the metal, you'll never have a kink. You should never have a kink in that metal. So we'll go ahead and probably do another test or two, another pull test or two. Then we'll scope out the roof, make some more comments and questions, and see what we can come up with from there.